Okay. Thank you. Okay, it's been recorded now. Okay, what can you understand from this particular chapter, class, before I begin? And before I continue where Dr. Zuki stopped last time, what can you understand from this particular topic, class? Can someone share with me? I just want to know what have you understood from the previous class so that I may repeat again whatever things that might not be clear to you. Okay, so that's why I'm asking. Okay, what can you understand from simple linear regression? The full topic is simple linear regression. Huh? My God, my pen got problem this morning. Simple linear regression. Testing, testing, testing. Can you hear my voice, class?
Yes,
Okay,
okay.
someone tell me that my voice is not clear. Okay.
Yes, yes.
Okay, thank you. Okay. Let me go to my OneNote again. Hopefully my pen is okay because I need to write a lot in this session. Aduh. Okay, everyone stay inside. I just need to log off everything and then turn on back because I want to make sure my pen is functioning well. Okay, I'll just leave for a while. Okay, class. Okay, I'm really sorry. I'm taking too much time with this technology. So I wish, I hope everyone is okay. Okay. So can you see my OneNote again, class? I think inshallah my pen will be okay now. Can you see my OneNote?
Yes, that's good.
Okay, thank you very much. Okay, thank you. Thank you. Okay, now, okay. Is there anything that you don't understand? Let me ask you that way. It will be easier for me to trace whatever things that you don't understand before I go further, because afterwards I'm going to show you how we can model our problems using simple linear regression and find out those things that we can analyze using simple linear regression. So before we begin, may I know, is there any of the contents that you need me to re-explain again, or maybe explain again to you? Is there any point that you don't understand? Anyone? Or everything is okay? You can understand the whole materials that the Tozuki has discussed with you? Now, if simple questions, okay. If you have X and Y, which depend on which? Is Y depend on X or X depend on Y? Can someone please tell me? When you are talking about simple linear regression, why we call it simple? Because we are dealing with one Y and one X. That's why we call it simple. If we have several X, so we call it as multiple linear regression, because we have so many X, okay, that we model to our Y. So which depend on which? X depend on Y or Y depends on X, class?
Y depends on X.
Okay, and that is why we call this Y is as the dependent variable. Sometimes we call it as, my pen is not working. I'm not sure why. Just now it's okay. Okay, that's why, class, please take note, those things, because my pen is not working. See, my mouse is running, but, oh, maybe because I didn't do, okay. This one, sometimes we call it as dependent variables, or we call it as response variable. Okay, if most of the time, if we call it the Y as dependent variable, the X will be independent variable. Okay, obviously you can see that Y is depending on X value. Y will change based on the X value, and how Y change is based on how the X change. Okay, if you call this as response variable, so this X will be, we call it as explanatory variable. How we can explain our response variable using our X. Okay, so that will be another things that you should know. So when you have problems related to simple linear regression, okay, uh, you might not be guided, okay, which one of the variable involved in your problem will be your X, and which one will be your X, it will be your Y. So when you don't know which one is Y, which one is X, so you have to think back. Okay, what will be the study for? Okay, what are you trying to figure out from that particular problem? Are you trying to figure out what? Okay, so when you have that particular situation, you will have to evaluate, okay, which one depend on what. So that will be where you can decide which one is X and which one is Y. Okay, so that will be basically about the simple linear regression. Now we know that when we are talking about simple linear regression, okay, we are talking about linear. Okay, what do we mean by linear? Something that has linear relationship. It's either this particular form, or this particular form, or this particular form. The relationship will be linear. Means that when you have one value, for example, the X value, if the X value increases, if let's say I draw out X and Y axis, okay, if you have X value increases, okay, from lower value to upper value, it increases, and the Y also increases. Okay, So you will have this particular line. As x increases, y also increases. If also, let's say you have this particular relationship, means that as x increases, y what? Decreases or increases, class? Y is decreases. Okay, how? Because we have, let's say this is 5, 10, blah 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 until 40. Okay, as x increases, the y decreases. Okay, so there will be also times where you don't have that particular, the linear relationship is exists, but there is no relationship. This is where you have this particular line. Okay, there is no change in y. Okay, y stagnant from this value to this particular value, but the x increases. So in this case, x increases, but y did not change. Okay, so this is where no relationship. So when we are talking about simple linear regression, we are talking about two variable that acting this particular form. Okay, is either both increases or the other way around, or as what we have in this one. Okay, so that will be linear relationship. And how do we know that this particular linear relationship exists? Okay, how do we test whether this linear relationship is exist? So can someone please tell me how? How do you know that the linear relationship exists?
By the dependency.
What was that?
By the dependency, if there is a variable that depends on the another on the other one.
Not really correct. Any other answer? Any other answer? What have you covered last week? There will be two, I think, two subtopics, two important subtopics that relate to this particular questions. Knowing that we know that we are identifying a linear relationship between x and y. Okay, there will be things that we need to know about this particular linear relationship. Okay, the first one is the strength. How do we know that our linear relationship is strong or weak? How do we know, class? By measuring what, class? By measuring what, class? To know the strength of our linear relationship between x and y.
Correlation coefficient.
Yes, finding the correlation coefficient, or we call it as R. Okay, so you have gone through how to calculate the R. And this is where the R will be giving you the information, the strength of your relationship. Okay. So your R will be what? From what value to what value? So you will have R between -1 until +1. Means that R can take place from -1, that will be the maximum value or the minimum value for your R, and it can be +1. Okay, and the middle will be 0. When you have R is equal to 0, means that you will not going to have what we call the linear relationship between the x and y. What does that mean, class, when you have no linear relationship? Can someone please tell me? From what you have understood from the first class about simple linear regression, when we say there is no linear relationship, what can you tell about the x and y that you are studying? Can someone try?
Y does not depend on x.
Okay, correct. Y is not depend on x, but what would be the meaningful information that you know when you measure the R, R give you equal to 0? I'm not sure whether Dr. Zuki mentioned about this, but from the previous discussion, you may have think about what is the meaning when we say no linear relationship between X and Y. Can someone try one more time? One answer, only one answer. If it is wrong, it's okay. I just want to listen to your answer. What will be the meaningful information that you can draw or you can conclude from when the R is equal to 0?
That there will be no relationship.
We are talking about no linear relationship, but what is the meaning from the X and Y?
It will be in straight line.
Yeah, I know it will be in straight line. For example, this one, R equal to 0, right? Could be, this will be the line. Now, what I meant here is that we are trying to understand how the Y behave when you have the X to support the Y. Now, you calculate the R and it turned out that the R is equal to 0. Okay, one thing when you have R is equal to 0, one thing that you can, I'm not sure to say conclude, but you can, at least you can assume when you have R is equal to 0, means that your selection of X, the variable of X that you choose to describe or to explain your Y is not correct. Means that you are choosing the wrong X, because the X that you have chosen is not even tell something about your Y. So that's why you have R equal to 0. So that is when we say the strength, the kekuatan linear relationship tu, when we are talking about the strength of the linear relationship, this R value can tells you how strong the linear relationship between the X and Y. So if R is equal to 0, you may know that your X you have chosen wrongly. Your X cannot tell about your Y. So you have choose another X that can explain your Y. And now, if that is R equal to 0, what if R equal to -1, perfect -1, or perfect +1? Okay, for example, you have this particular diagram. If you draw the line will touch every single point on the diagram. Okay, so this is +1. The same goes to -1. If you have perfect, means that 100% strong relationship between X and Y, means that your plot on the line touch every single point. The line will touch every single point. So this is what we call perfect correlation coefficient, or we call it as what? The name is sample correlation coefficient. Okay, now as you know, as X change, okay, you may choose the X that not really explaining your Y. This is where your X will be a bit distributed along the line. If we draw a line here, for example, let's say this is the line, you can see more points are distributed away from the line. So you can see there will be distances from points to the line. The same goes to the negative relationship. If in this case you have negative 0.5, this one is positive 0.85, you can imagine the distributive away points to the line, the less the R will be. Okay, as you can see here, R is equal to 0.2, then the points are much distributive away from the central line. If let's say this is the line, so the distances from each point to the line much bigger. Okay, so that's how R tells you about the strength of the correlation. Now, knowing that there is the strength value that we can calculate for our linear relationship, how to explain or how to prove that this particular linear relationship exists, then only you have to test using what we call hypothesis testing for the correlation coefficient. Now, if you can still remember our discussion on chapter 2, chapter 3, chapter 4, Okay, when we are talking about hypothesis testing, do we test the statistic or do we test the information from the population? Can someone please remind me back? We are testing the population value or the sample value? Class?
Sample value.
Sample value.
Wrong. When we are, remember class, when we are talking about population statistic, we cannot study the whole population, we choose the sample, and the way we collect the sample, we are using some sampling method. And when we choose from our sample, let's say this is our population, we cannot choose everyone, so we choose subset. Let's say the subset is just to give you the idea of the subset is part of the population, and this part of population is the one that we gather the information, we collect the data, and then from this particular data we do some analysis. When we do some analysis, okay, we analyze. And then when we analyze, when we want to make the conclusion, and this is where we have to remember, what do we want to conclude? Do we want to conclude about the sample or do we want to conclude about the population, class?
Population.
Yes, we are studying the sample, but at the end of the day, at the end of your analysis process, the conclusion is reflecting your population. That is why earlier on in chapter 1, I remind you, maybe in chapter 2, I remind you, the way we choose our sample must be representative of your population, so that when we analyze our sample is actually represent the whole population that we are trying to study. So when we make conclusion, this is where we go back to our population and we do some testing. That is what we call as hypothesis testing. When we do the hypothesis testing, we are testing the population value. So in this case, okay, class, we are testing the row. Okay, we are testing the row. The row reflect the linear relationship between the X and Y for the population. Okay, so that's why we have this row. And the way we check for the row is either equal to 0 or not equal to 0. And equal to 0 is meant by this, and not equal to 0 is meant by this. So what do we want to have is when we perform our hypothesis testing for the correlation coefficient, we wish to have sufficient evidence to support this H1. Okay, so that we can prove that there is linear correlation between the X and Y that we are investigating. So far, can you understand, class? Okay, class? So I hope for your chapter 4, okay, so please, I'm not sure whether you have studied or not chapter 4, because you are going to have your quiz regarding your chapter 4, if I'm not mistaken, somewhere tonight, right? So hopefully everything would be okay. Okay, so this is where you have listened to what Dr. Zuki has what we call explained to you last time. So we are using our T distribution, and when we are referring to T distribution, okay, let me go back to the T distribution. Okay, your T distribution is something look like this. Okay, it is a normal, kind of a normal distribution, but sometimes we call it as student distribution. Okay, it's much smaller than the Z distribution or the normal distribution. So what do you have in your T distribution is the first column would be the degree of freedom. So the degree of freedom is reflecting your N value. N, I cannot read right now. So the N value reflecting the sample size, the number of data point that involved in your analysis. Okay, and V is -2 if I'm not mistaken. Okay, yes. So you can see here, V, this is your V, your degree of freedom. Okay, the sample size value -2. And this is the alpha value, the critical region that you have in your T distribution. And if you're talking about T distribution, and sorry for the not really good distribution. So you have equal, not equal to means that you are having two tail tests. Okay, so that's why you have alpha over 2. So this is where half of the alpha, and this is another half of your alpha. And this is what we call as the rejection region. Okay, so if you calculate your t-test, if your t-test fall between this particular region, okay, so we say that reject null hypothesis. Okay, reject null hypothesis. If it falls in the non-rejection region, okay, so here fail to reject null hypothesis. Okay, so that's how we do the decision making. So having said, you can find your critical value. So this is your critical value. So this is your t value over here, negative t, and this one is t positive. Okay, so you will have your test statistic based on your calculation, and you will compare, and this is where the green falls, either in the non-rejection region or the rejection region. Then you can decide, okay, whether it will be fail to reject or reject the null hypothesis. So that will be how you can answer back my question just now. Okay, that will be how to know that there exists linear relationship or correlation between the X and Y. Okay, so that's all for the revision before we can start with the next subtopic. Okay, is there any question, class? Any questions so far, class? No, huh? Okay, if no question now, just to review again what do we mean by linear relationship, or we call it as positive or negative linear relationship. So you can see here is positive linear relationship. Okay, positive linear relationship means that when X increases, Y also increases. For example, if X somewhere here, okay, your Y is somewhere over here. If your X is over here, then your Y is somewhere over here. Okay, so that's why as X increases, Y also increases. So that would be positive linear relationship. Okay, what about the beta naught and beta 1? We'll discuss afterwards. Okay, now what about negative linear relationship? Okay, as X increases, Y decreases. For example, as X, for example here, your Y is somewhere over here. As X increases, your Y decreases. Until the last point here, you will have your Y smaller than the previous point. Okay, so that is how we identify our negative linear relationship. Okay, and if there is no linear relationship, so you can see, okay, your X increases, but your Y stagnant. No change in your Y. Okay, now there will be times where you have to what we call determine your regression, or what we call your plot of your regression. Okay, so a linear regression can be developed by freehand plot of the data. Now, if you're talking about very small number of data, then freehand plot will be okay. But if let's say you have hundreds of points or thousands of points, I think freehand plot will not be advisable for you. So it's where you have to use your at least your Excel to help you out with the plot of your regression. Now, if let's say just to have some discussion on this particular freehand plot, afterward I will show you how you can use your Excel. So I hope everyone who are using your handphone or using your laptop, you can start opening your Excel so that you can experience on your own how we can draw the regression or the scatter plot of our data using the Excel. Now, if let's say we look through this particular example, 10.2, okay, let's say the given table contains value of two variables x and y. Plot the given data and make a freehand estimated regression line. Okay, let's say you are given this particular value, x, where x negative 3, your y is positive 1. X negative 2, y is equal to 2. And if let's say x is equal to 3, your y is equal to 12. So how do we plot? Easy. So if let's say you have your x and y exist. So this is your x and this is your y. Okay, so your first point is negative 3, 1. Okay, and if you can see, okay, class, for this particular data, the data has been sorted for you from the least value to the maximum value. Okay, basically we go for the x value to arrange or to sort your data. So when you have x equal to negative 3, okay, your y is equal to 1. Okay, 1 is somewhere over here. So this is point where you have negative 3, 1. Your second point would be negative 2. Sorry, your second point is here, negative 2, 2. Your third point is negative 1, 3. Okay, the same goes here is 0 and 5. This one here is 1, 8. This one here is 2, 11. Okay, and finally you have 3, 12. So you begin with your x and then continue with your y. So this will be how you can have your freehand plot. Now, how do I draw the linear line? Okay, if let's say you are connecting the line, so you will have this particular yellow line. Okay, connecting point to points. But in order to, for this particular case, in order to talk about the linear relationship between the x and y, what do we want to have is a linear line along the points that you have on the scatter plot. So the way we draw the line will be the one that best fit all the points that you have. Okay, so if let's say in this case, this will be the linear line that we are looking for. Okay, let's say this is the best linear line. How? There will be ways on how to determine, how to draw the best line that can fit to your scatter plot. Okay, but in this case, let's say this is how we can draw the line, and this is the best line that you can have for your scatter plot. Okay, so now for this example, okay, the result of statistic, let's say we are trying to draw this particular what we call regression or scatter plot. Okay, regression plot or scatter plot for this particular exercise. What is the question? The result of statistics subject for Faculty of Computer students will decrease semester to semester. So the first sentence tells that the statistic result has decreases from one semester to another semester. The dean needs to know whether the class size and grade achievement in percent were related. So the deans wish to know, okay, how the class size and grade achievement will relate to each other. Okay, In other words, the deans wants to know, is it because large class cause that the test result decreases or what? Okay, so in this case, we are talking about class size only. Okay, the following table lists the number of students for each class and their average grade in percentage. Construct a scatter plot for the data. Determine the type of relationship for the data. So you have two tasks that you need to complete. The first one is to draw something like this, the scatter plot only. So when we are talking about the scatter plot, we are talking about the X and Y and the plots only. This is what we call as scatter plot. Okay, so from this scatter plot, okay, determine the relationship. So in order to determine the relationship, you need to, if this particular relationship, obviously we can say, okay, this is positive linear because it is increasing. As X increases, Y increases, for example. But we don't know in this particular case. Okay, so once you have got your what we call scatter plot, you can determine using the line that you can, draw from your scatter plot. Now, for this particular case, I would like to use the Excel. Okay, and before we go for the Excel, okay, let us, okay, just go through freehand drawing from this particular exercise. Okay, so we have for the first one, number of student 15, average grade 85. Number of student 10s, average grade 90. Until you have number of students 25, you have average grade 75. So draw your X and Y. So this is your X. This is your Y. Now, my question, class. How do I know that X will be number of student and my Y will be average grade? Can someone tell me how, class? Why X number of student, not Y is number of student?
Based on dependent thing.
Yeah, based on dependent. So what about your dependent variable? What about your dependent variable that you wish to?
Dependent student.
What was that?
Number of student.
The Y is number of student or average grade? The Y.
The Y. Y the average grade.
Yeah, Y average grade is the Y, not X. Why? Relate back to the question just now. Class, this might be your question that you need to answer. And how do you know that number of student is my X, average grade is my Y? Okay lah, obviously I have shared with you my answer here. But if let's say you have your question here, how would you determine which one is X, which one is Y? Okay, that's reflect my question. Why average grade is becoming your Y? Anyone wants to try?
Doctor, is it based on the question?
Yeah, I know, based on the question, what the question wants you to do.
Because
we need to see what thing is depend on something.
You want to investigate, is it correct that the grade achievement is determined by the class size? That is what the deans wants to know, right? So the deans wants to know whether the grade achievement is really depending on the class size. So if it is really depending, means that later on, maybe the deans need to adjust. The class for statistic must be in small number. If let's say big number of students in one class will cause decreases in the result of statistic test, then the deans might want to change the class size for statistic would be smaller than usual. So that will be the overall, discussion about this particular question. So that's why you put the average grade as your Y, because that is the result from your class size, right? So that's why in this particular case, we decide that the response variable or the dependent variable is the average grade, where we believe this average grade is depending on the number of students. And from this particular record value, okay, when we plot them, 1585. So in this case, the value is not being what we call sort to you, okay? The smallest x is 6, okay? 6 over here. So you are talking about 6. So this is the first point, 6, 92. Then you have second point, 8, 8, 82. Okay, 8, 82. So draw them on your what we call graph paper, or if you are using your Excel, it will be simple. So plot them accordingly. So when you have this particular drawing, we can assume that, okay, it seems like, yes, it is decreasing, okay, as what the line tells you. So in this case, the answer for this particular question was what, class? Construct a scatter plot. So when you have scatter plot, if the name of the axis is correct, okay, that would be 1 point. Your scatter plot everything accordingly, that will be another point. And if, let's say, in this case, you need to draw the line can be another point. So this will be all the 3 marks that you can get from these particular questions. Okay, now class, what if we are using Excel? Okay, let me bring you to my Excel. So if you have your Excel with you, you can open your Excel. Okay, the way we key in, as for me, I would like to put them in terms of column form, sorry. So let me copy this. Okay, let's say we have this. We are not talking about this question, right? Let's say we copy this from, where's the question just now? Okay, we have this. Okay, let's say we have this, and then we wish to, okay, can someone tell me the data value? Because I would like to open my Excel. Number of students. How many number of students? 20. Can you tell me, class?
20,
Uh-huh.
8,
8,
15.
15,
Oh, no, bukan 15. 18 first, 18 first.
18, and then
Okay, and then 15.
15.
And then we go to, oh, actually there's one.
Uh-huh.
The worst is 75. So yang first kali tu 25.
Oh, 25, okay.
Okay, first 25.
8,
And then 20.
20,
And then we go on to 8.
8,
And then 15.
15.
Tahu tak? Okay, saya ada tertinggal ni.
Dia ada 8 kan?
Ni 8, yes.
15, 10. 15, 10, 8, 20. 15, 10, 15, 10, 20.
Oh, ni kau tak ikut susunan.
Oh, you, okay. Tak ikut susunan pun tak apa, it's okay. Just give me. Pak semula saya pun dah tak ingat dah.
Okay.
Okay, 15, 10, 8. Okay. 20,
18,
18,
6,
6,
25.
25. Average grade. Because class, for your chapter 5, you are not going to have your assessment, test or quiz. For your chapter 5, you will have your assignment. Your assignment, you will have you to do all the calculation using your Excel. So it will be easier for you. No more calculation using hand calculation. We are going to use our Excel to generate all the answer for you. It will be easier for you, okay? So average grade, please tell me.
85,
85,
90,
90,
yes, 90, 82,
82,
80,
80,
84, 92,
92,
lastly 75.
75. Okay, so we know that number of students is our X. Okay, and average grade is our Y. Okay, so in this case, okay, I would like to show you how we can use our data. So go to data in Excel, you can see data analysis here. If let's say you don't have this particular data analysis, you have to go to your file, go to more, go to account. No, more. Sorry. Hold on. Go to file and then option. Okay. Go to file, go to option. Okay. You have to install the data analysis. This particular, my mouse is go to the data analysis here, because if you don't have the data analysis in your Excel, you cannot do the analysis for your simple linear regression. So where do I install? How do I install? Go to add-ins. Okay, double click add-ins. Okay, and then you can see analysis tool packs. So click here. Okay, then click Excel add-ins and then go and then click OK. So in my case, I've already got my data analysis. So add-ins, double click analysis tool packs and then go. Okay, so if let's say I click go, so you have to click this. If you don't click, you will not going to have this particular data analysis in you. So click this analysis tool packs and then click OK. Click OK, then it will appear in your Excel. Can someone please do? Okay. Is there any problem in installing this data analysis? Okay. Can someone successfully install your data analysis in your Excel? Or you have already got your data analysis?
Okay, Dr. Ken already.
Okay, thank you. So you go to your data analysis. So the things that you have before this, that will be the sample correlation, the R, you can calculate using this. Okay, go to OK, go input range, highlight all the value, including the axis name, the X and Y name. And then since you have your X name, so label in the first row. And then we arrange using column. Okay, I'm using my column, so I click column. If you are using your row, so let's say your second row is reflecting your X, third row is reflecting your Y, then click row. In my case, I use column. Let's say I would like to have my input range somewhere over here. Okay, then click OK. So I can get my what we call sample correlation of my X and Y. Okay, so this is my kejap ya. Dia tak kena ni. Something is wrong here. Okay. Let me do it again. Should be okay. Okay. Data analysis. Oh, I'm using my covariance, not correlation. No wonder. Okay. Click correlation. Okay. Input range. I like the input range X and Y. And then group by column, label in the first row. And I want my output range near my table here. Okay. So I have my what we call correlation coefficient for my X and Y that I am investigating. So see, I have negative 0.8. So automatically can be generated using this particular data analysis. Now, how to do the scatter plot? Okay, I believe everyone know how to use Excel. I think this one is very basic. I know some of you may have know how to do. So go to insert. Okay, you have your data ready. Go to insert, and then you can choose. You can see here scatter plot. Okay, insert scatter X and Y means that you want to include to choose the scatter plot. So choose this particular scatter plot. Okay, now you can automatically get your scatter plot for this particular problem. Okay, now when you see your slide here or you see your graph here, you don't have the axis name, so you can add. Where you can add, how? Go to chart design, go to add chart elements, and then choose axis title. So begin from X. Okay, click at the axis title and then number of students as your x-axis. Okay, double click again. If you want to add, make sure this circle point is somewhere along your what we call diagram. Okay, then add your y. So go to axis title, then go to y. And then for y, you double click here, change the name, average rate, in bracket, percent. Okay, now what you can see from this particular diagram, if you compare with your answer just now, is not really maximizing the diagram of what we call surface. Okay, so this one is not really at this particular point. You can see it's kind of wasting here. Okay, so we don't want this particular drawing inside our diagram. So what you can do, you can adjust your y. Your x is okay, seems to be okay, but your y, because it begin from 0, you can ask the diagram to begin somewhere from maybe 60 or 70. So here, go to plus sign here, okay, and then go to axis. Okay, go to axis title. Chart title, data label, if I'm not mistaken, is which one? Don't know. Create lines. Sekejap ya, dah hilang dah saya punya ni. Sekejap ya. Okay. Undo balik lah. Okay. Okay, I stop here. So I would like to do some changes in the y-axis. So I go to axis, more option. Okay. Now, when you go to more option, axis option, you go to, let's see, you have the bound, the maximum is 30 for x. So for the unit measure is 5. Okay, correct? 5, 10, 15 until 30. Now you go to your y. Okay, how do I go to my y? Okay. Okay, go to y. So you click here is x. You click here, it will change to your y. Okay, so click here, it give you the x-axis. You click here, it will go to your y-axis. Now, I want to have the maximum as 100, okay, but I don't want the minimum as 0. Let's say I change to 50, for example. Okay, and then enter. So this is where you change the axis, begin from 50. Since it is not really good, so let's say I change to 60 and then enter. So this is how it looks like. Okay, maybe I would like to have this in my scatter plot, so you can stop. Okay, so this is your scatter plot. You can change the title. Okay, you can say as the scatter plot for grades, average grade and number of students. Okay, so you can adjust the value or the font size, okay, and everything. So this is how you can change your scatter plot. So much more presentable compared to your this particular diagram. Okay, so this is how you can adjust your scatter plot. Now, the question is, what was the question just now? The question asks whether, okay, construct a scatter plot, done, determine the type of relationship for the data. So what can you tell about the relationship from the data class here? What can you tell? Positive or negative linear relationship?
Negative.
Yes. So, scatter plot done. So, linear relationship. Okay. So, we know that grade, average grade and number of students has negative linear relationship. And you can observe this particular negative linear relationship from this particular R. So this is your R. We call it as capital R or R only. So this is your capital R or R. Sample correlation coefficient value. Okay, any question so far, class? Any question so far, class?
No, sir.
Okay, thank you. So next we are going to use our Excel, but let us look at our notes first. Okay, what will be the discussion that we can have from our lecture notes? Now, you have gone through how to know whether the X and Y that you are investigating has what we call the linear relationship, either the positive or negative linear relationship. And from this particular linear relationship, you can tell whether the linear relationship is strong or weak. How do I know it is strong? If it close to -1 or close to +1, it will tells you that the strength of the linear relationship is strong. But if the R value close to 0, means that the linear relationship is weak. So in our case just now, our R value is -0.8. Do we consider -0.8 as strong or weak linear relationship, class? This one, class.
Strong.
Strong, right? So it is almost to -1. So we consider this particular grade and number of student has strong linear relationship between the two variable. Okay, now, and we can in this case we can prove that the correlation coefficient, the strength that we get from that particular values at -0.8 is strong, and we can support that using the hypothesis testing. So you can repeat the hypothesis testing that you do previously, repeat for this particular example. Okay, so do you want to go for hypothesis testing or what, class? Do you want me to go through the hypothesis testing? Let me give you as your exercise, class. Check for the hypothesis testing of the correlation coefficient. This 0.8 is actually, do you have the evidence to support or do you don't have the evidence to support? Okay, I want you to do it. Okay, now, next will be the simple linear regression. What is simple linear regression model that we are talking about in this case, class? Okay, we are talking about X and Y. We know the linear relationship is either positive, negative, or no linear relationship, flat. Now, how do we model this? And the way we model is using what we call simple linear regression model. So this is the name, simple linear regression model, SLR. And this SLR is described by using this particular equation. Y hat is equal to beta naught plus beta 1 hat X. Now, this is actually estimated model. When I say estimated model, remember class, previously we have our population, okay? And we know that we cannot study the population. We only select some part of your population to become your sample, okay? And from this particular sample, you collect your data, and then this is where your data you get, and then from this particular data, you model this particular linear relationship using y hat is equal to beta naught hat plus beta 1 hat X. So this is what we call estimated because we are using our sample. So what if we portray our model for our population? Can. So the model for our population will be y equal to beta naught plus beta 1 X plus epsilon error. So this one is for error. Okay, but this is the model for your population. And since we don't have the data for our population, we are estimating the model using the sample data. So now our discussion is based from this particular point. Okay, using our sample data, we would like to find what would be the equation of this particular line. Okay, what will be the equation of this particular line? Okay, and we know that if this is negative, okay, if this is negative, what will be the slope? Just now, the slope is at beta naught. Slope is beta 1, sorry. So beta 1, if you have negative, okay, negative, so this one would be y hat plus beta, y hat is equal to beta naught hat negative beta 1 X. Sorry. So portray negative relationship. Okay. So obviously, so if positive, your relationship will be this way. Okay. Now that will be told by our model. And the way we calculate this particular beta naught, beta 1, you can follow this particular concept. So to calculate your beta naught, you can use the mean of y, the mean of x, multiply with the beta 1 hat. So how do I get my beta 1 hat? So you can use this particular equation to find your beta 1 hat by you finding what is x, x, y, x, x, s, y, y, s, x, x, and you put into your equation and you can find your beta 1 hat. Knowing what will be your beta 1 hat, you can find your beta naught hat. Okay, so all the calculation, the manual calculation can be seen here. Okay, for example, this particular example. Okay, you are talking about a mathematics score, mathematics 1 and mathematics 2. Okay, of course, in order to take mathematics 2, you have to take mathematics 1. Okay, let's say this is a prerequisite courses. Okay, so in order for you to enroll for mathematics 2, you have to enroll for mathematics 1. So obviously in this particular case, your maths 1 will be your x and maths 2 will be your y. So you can predict your, or you can find the value for your y based on your value of your x. Finding the value of your maths 2 based on your maths 1. Okay, so the question is develop an estimated linear regression model with math 1 as the independent and math 2 as the dependent and predict the score a student would obtain math 2 if he scored 60 in maths 1. So we would like to have this in Excel. Okay, so if you are using your manual calculation, you have to find, you are given your x and y, you find your x squared, find your y squared, find your xy. Okay, so from here you can use all this value, okay, to find the average for x, average for y, beta naught hat, beta 1 hat, and everything. So you can calculate. Okay, and finally you can make your prediction. But now how we can use Excel to help us out for this particular problem. Now let's say okay, go to Excel. Okay, if you have your Excel with you, why don't you try key in your data in your Excel according to X and Y. While I'm trying to copy my data. Okay, so let's say you have this particular value for your math 1 and math 2. Okay, so we are using our Excel to help us out with the whatever calculation needed. Okay, so let me retype again. So you have math 1 and then we have math 2. Our y. So we have 65. If you have anything to ask, you can stop me anywhere. We are not going to have our rest, okay, until we finish at certain slide, okay. 68, 57, 36, 96. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then we have 68, 66, 86, 48, 65, 66, 71, 57, 42, 87. Okay. So make it presentable. Okay. Now, we begin again from the beginning part. Okay. Let's say we do the... Now, in this case, I would like to show you how you can actually do the data analysis even simpler than what I did just now. Okay, so go to data analysis. Okay, go for regression. Okay, you have the word regression here, and then click OK. And then identify your Y range. So my Y is for math 2. And my X will be math 1, including the axis name. And then I would like to Excel know that my label is at the first line. Okay. And from the question, you need to, let's see in this case, okay, never mind. Okay. You want the output range somewhere over here. Okay. So D4 is where you want to locate your answer. So D4 is somewhere over here in my mouse here. Okay. So then click OK. See, everything has been generated for you. Okay. Even you got your ANOVA that the things that we are going to discuss further in your lecture notes. Okay. Now, in this case, okay, what will be the information that you need to know? Okay, the multiple R. This multiple R is actually your R. Let's say we use R, small r, okay? This is your sample correlation coefficient. Okay, so let us check. If you don't believe, you can check. Okay, go to data and generate the correlation just now. Okay, your answer, your data, and then column label, you want your answer to be somewhere over here, then click OK. See, this is your sample correlation coefficient, your R. Okay, this is your R. Now, finish with one question. Now, from the question given to you, okay, you need to develop the linear regression. What you can do now, go again to your insert and then scatter plot. Choose this scatter plot, and then you should highlight the value just now. Okay, scatter plot. Now, this is your scatter plot. Let's say we put here somewhere here. Okay, I do it again. Okay, go to add chart, add the chart design. Okay, go to X. X is for math 1. Okay, double click and then go to axis again, go to Y and then change to maths 2. Okay, title you can change. Okay, regression, or you wish to write as simple linear regression for math 1 and math 2, for example. Okay, I would like to have my regression line. How do I write down, or how do I add the line? So if let's say we would like to adjust so that the diagram should be look even better than this one. So we don't need 20 here. Maybe we can start from 30 for X and 30 for Y. So go to this plus sign, go to axis, okay, go to more option, okay, begin with X first. Oh my God. Axis. Everything will be changed automatically. So you have to be careful. More option. Okay, it's already highlighting the X axis. So you want the X axis begin with 30. So put minimum 30, for example here. 30 and then enter. Then change to the Y, begin with 30 as well, and then enter. So your scatter plot look even better. Now you would like to add the trend line. Trend line means that you want to add the trend line here. Okay, so go to this trend line and then go to more option. You want to have your trend line to have the equation. Okay, go again to trend line, more option, and then scroll down. Okay, you have option over here. Set the intercept, display equation on chart, display R squared on chart. So let's say I'll just click the one that I need. Okay, I would like to have the line to show the regression equation. So now click, automatically it will be generated to you. Okay, and the other one will be R squared. R squared is the one that we are going to discuss afterward. If let's say we just click here, okay, so our discussion will be even easier later. So let's say this is our scatter plot along with the trend line, okay, and in this case we can adjust the equation line, we can increase the font value so that it will be easier for you. Okay, okay class, so but now your equation does not really looks like as what you have in your notes just now. So you have in your note, okay, you have in your note something like this one, right? Okay, something like this one. Now, if let's say taking our answer from our Excel just now, okay, it will be, let me write down on my paper, 0.8237 plus 12.306 x. Okay, class, it is written this way, right? Okay, so let me, can I copy and then paste somewhere here? Okay. Okay. Okay, where's my question just now? Okay. Okay, using our Excel, okay, using our Excel, we can generate our answer for this particular question. So in this case, class, okay, so we know that originally your equation looks like this. Y hat is equal to beta naught hat plus beta 1 hat x. Okay, so this is the slope. Okay, and this is the intercept. Intercept is where it crosses the y value here. Okay, so this is beta naught. So this is beta naught hat. Okay, so in this case, this one, if we rewrite again, it will be y hat equal to 0.8237x plus 12.306. So this is your beta 1 hat and this is your beta naught hat. So we know that this 12.306 is where it crosses the y-axis, but in this case, it's not really 12.306. Okay, maybe because I changed the scale just now, so it changes a bit, okay, from this particular value. So this is the slope, and if we go to the note just now, the the interception will be, see class, this is where the interception looks like. This is the value where the interception takes place. Okay, I believe because of my adjustment of the x just now. Okay, because it should be begins from 0, 0 just now, but I changed this. It's okay, never mind. Okay, but the slope tells you that it is a positive value. Okay, it is a positive value and it clearly reflected from the line here. So the line shows that it has positive linear relationship, and the equation is something like this one. Or we can show using the generated Excel as this one. Okay, and we know that our R, the strength of our correlation for this math 1 and math 2 is very high, 0.94. Okay, 0.94. So in this case, R is equal to 0.94. Okay, very strong. Not very lah. We can say just strong. Okay, strong. Strong linear relationship. Okay, you can test. You can test for your hypothesis testing. Okay, test for rho is equal to 0, rho is not equal to 0. So you can test whether you have evidence or not to support that, yes, this particular problem has strong relationship between math 1 and math 2. Okay, so far class, do you have any question? Is there any question related to the discussion just now, class? We haven't answered question B, eh? Okay, class? No question? Now, the next question for B, are you all okay? Are you all with me or not? Okay. Even though you don't reply my answer, my questions, so it's okay lah. Yeah.
Okay, doktor.
Okay, thank you.
Cuma nak kena pakai application ni lah.
Yeah, betul. You can try afterwards, okay? If possible, I will share with you my template here that I've, conteng-conteng ni nanti saya share balik dengan kamu along with the Excel sheet, okay? I will just upload in the e-learning, okay? In the e-learning room. Okay, now the question B predict the score. Now, the keyword here is predict, okay? Now, the reason why we perform simple linear regression is because apart from figuring out whether the linear relationship is positive or negative, whether the linear relationship is strong or weak, okay, whether we can have evidence to support whether the linear relationship is okay, supported by your hypothesis testing or not, okay. And then once you have got your regression equation, okay, what would be the most important part by using your regression equation is to make prediction. Okay, the most important part in using this simple linear regression is to predict your y based on your x. Okay, but the rule for make prediction for this particular simple linear regression is basically begin from the least value of x until the maximum value of x. So if let's say your x is somewhere over here, this is the minimum value, and your y, your x maximum is somewhere over here, class, your prediction can take place only from this region only. Okay, this is where the prediction apply. Okay, so that's why in this particular case, the question asks you, if he scored 60 in Maths 2, what would be the the Maths 1 score. Sorry, if he scored in Maths 1 is 60, what would be the score for his Maths 2? Means that by using the X value, okay, what would be the Y value? Okay, so you are talking about 60. So 60 somewhere over here. And 60 for Maths 1 will give a prediction value for your Maths 2. So what is the value over here? Okay, so somewhere over, let's say maybe 63 maybe, I'm not sure. So if you can calculate using this particular equation. Okay, you take the X value, replace in the X value, and then calculate for Y hat. So this is your Y hat. So it is 61.73. So here is actually 61.73. Okay, 61.73. So this is your Y hat. So this is your X and Y hat. Okay, so that will be your prediction. What if I ask you, if he scored 100 for Maths 1, what would be the Maths 2 value? Can someone tell me? What if the Maths 1 is equal to 100? What about the prediction of Maths 2? Can someone tell me? Class? Can someone try? If
Repeat.
Huh?
Betul tolong repeat kejap tadi tak dengar.
Okay, if my question is, what if the student scored 100 in Maths 1, what will be the predicted value for his Mathematics 2?
Cannot, right?
94.676.
Is it correct? Any comment from the rest of the students?
Same.
Same.
94 more than 676.
Any other answer?
It out of our boundary, isn't it?
Yeah, I already mentioned just now. We can only make prediction within the boundary of the X value. We cannot do prediction beyond. Means beyond, somewhere over here cannot, somewhere over here cannot. So prediction for simple linear regression can only be done within the X range, from the minimum to the maximum value. So if let's say someone asks you, okay, what if he get 100 for his Maths 1? What about Mathematics 2? No, we cannot do that because it is beyond the prediction value. Okay, so that's how we can answer for this particular question. Okay, understand class? I simply ask you the things that I've just mentioned earlier, just to see how many of you are alert with the notes. Okay, so far, is it okay, class? Okay, class.
Okay.
Okay, now, for the exercise, I want you to do using your Excel. Plot using your Excel, do everything using Excel. Okay, correlation, coefficient, everything using Excel, and then interpret. Okay, the interpretation part, if you have got any problem, discuss again during the class. Now, I would like to continue with the 5.3, that will be adequacy of the model coefficient of determination, that is R squared. Okay, so what is R squared, or what is coefficient of determination? Just now, R is what? Sample correlation coefficient, right? Okay, it shows, or it tells you the strength of your linear relationship. Now, you have another one that will be R squared. Okay, R squared is the coefficient of determination. What does this R squared tells you? Okay, so in this case, it does not mention somewhere here. So in this case, look at the one that I highlighted here. That is what meant by the R squared. Okay, R squared tells that the variation in your dependent variable of your y accounted for the variation in your independent variable of your x. Means that how much the variation in your y accounted or explained by the variation in your x. So means that the higher the value of your R squared, the better the model is. Okay, because why? The higher the value, the more the x can tell us about the y. Okay, so in this case, your R squared, if I may write down, tells the contribution of x to y. Simply say that will be the simplest way to say. But in order to, conclude, this would be more helpful. Okay, so go back to our equation just now. Where do I get my R squared? Automatically can be generated using Excel. 0.8866. Okay, if I go back to my Excel just now, what is my R? My R is 0.94. What is my R squared? My R squared is 0.8866. Is my linear relationship strong? Yes, because the R value is near to 1. Okay, is my model good? Yes, because the R squared is nearly to 1. You got 0.8866, or if we put it to 2 decimal point, it would be 0.89. Okay, so does R and R squared related? Yes. How related? Okay, see here again, class. Okay, if your R is equal to 0.9, then R squared is 0.81. So my R just now is 0.94. Okay, so R is equal to 0.94. R squared equal to 0.94 squared. Can someone please calculate? You should get 0.8866. Is it correct, class?
Oh, yes.
Yes. So that will be the relationship between R and R squared. Means that once you got your R sample correlation coefficient, you can automatically find your correlation of determination by squaring the value of your R. Okay, so both value are having a relationship to each other. So once you have got your R, you can get your R squared, and then you can interpret. So in this case, class, okay, our R squared is equal to 0.8866. So what can we tell from this, class? Using the same exact example, what can we tell? Maybe I can write somewhere here. Okay, about the R squared just now. Is equal to 0.8866, or we take as 0.89. Okay, or we can say 89%. So 89%, just to look at the way the sentence, okay? 81% of variation in math 2 can be explained by the variation in math 1. Okay, so means that our selection of math 1 to describe our math 2 is good. Okay, so we are choosing the correct x and the correct x for our y. Okay, so in this case, the selection of variable is okay. Okay, in terms of explaining the y. Any question so far, class? Any question? I'm going to share with you the slide that I conteng-conteng ni in the e-learning. The same goes to the Excel. Now, the value for your if you got your value for R, okay, for R, okay, for R, the value will be either -1 to +1. So for R squared, the range will be from 0 until 1. Okay, or you can say from 0 in terms of percentages, 100%. Okay, 0% until 100%. Okay, so that will be the range for R squared. Okay, so if you wish to calculate by hand, so you can follow this particular what we call process in finding using the calculation manually. Okay, class. Okay, I think I would stop here.